aggregate. Okay, till now we have done aggregate test that is based on the impact, that is the impact test and crushing test. Next, today we will discuss about the abrasion test, that is the Los Angeles abrasion test. Los Angeles is the name of the instrument. On that this abrasion test is performed. Now why abrasion test is required to perform for your transportation lab is that in practical scenario, when there is a pavement and the vehicles are moving over it, the surface of the pavement is prone to get abrasion, okay, because of the wheel, the load of the wheel that is coming on the surface. Okay, there may be abrasive force may be due to heavy vehicles, okay, or maybe if some vehicles that are mounted with pneumatic rollers, okay, like your tanks or some good cars where their wheels are having metals, so they will give you certain impact on the surface in terms of abrasion. Okay, means there will be some rubbing action. Okay, so to test that, how much load, how much abrasive force that the aggregate can carry, we perform this test. Okay, from this test we will understand that we can judge that how much abrasion the aggregate that has come as a sample for the construction of the pavement, we can carry out the whether it is safe or not. Okay, whether the aggregate can carry the abrasive load completely or not. Okay, so to perform this, we need your apparatus, your machine, that is your Los Angeles abrasion test. Okay, it consists of a steel drum. The dimension of this drum is dia is around 700 mm and the length is about 500 mm. So we will fill this drum with aggregates, okay, of certain quantity and some steel or your mild steel or your iron cast balls. Okay, certain number of balls of certain weight specification. We will fill it and this drum will be rotated. Okay, at a certain RPM, around 33 RPM it will be rotated. Okay, uniformly, and after that, for a number of times, around 500 to 1000. Okay, based on the grades that I will discuss. So based on this grade, it will be rotated. And after the rotation, we will take out the aggregate and we will sieve it. And after sieving, we will check how much the quantity has passed. Okay, passing by the initial into 100 means the percentage passing, we will check. And based on that, we will judge whether our aggregate is functional or not. Okay, so for this, we have to first do the sieve analysis for grading of aggregate. Because as I have told you, there is abrasive charges, okay, number of steel balls. So this the inside your Los Angeles machine, you have to insert your aggregate, okay, aggregate of certain specification, certain size, plus your abrasive charges. Okay, these are what steel balls or cast iron balls. Okay, they are inserted. So how much quantity of aggregate and how much quantity of number of cast iron balls need to be put inside this apparatus depends on the grading of the aggregate we are using. Okay, based on the size of the aggregate. So there is a specification in the IS code where we can check how much grade it is falling for the particular range of the aggregate, size of the aggregate. Okay, so it starts from 80 mm when it is passing on 80 mm, it is on 63 and 63 and 50 and so on. So based on this, we have graded classification. Okay, so here in our test we will take the range of 20 mm, the aggregates which are passing on 20 mm, retaining on 12.5, and another range passing on 12.5 with 40. Okay, we will take quantity of around 5 kg. So from A, B, C, D up to this range, the weight of sample is to be taken is 5 kg. And beyond your D, that is here G, we have to carry the sample of 10 kg. We have to carry the sample of 10 kg. Okay. So if you see the chart, so for my grade will be E. If my aggregate is passing to 80 mm and retaining 63, so it will fall under E grade. This range. You have to carry 10 kg of sample of first initially 80 to 63 years, 2.5 and 2.5 kg, and next the 50 mm for your another 5 kg. Okay, so like this way, if my sample size is 40. If it is in this sample size, then it will fall under the range of F, under this 1 5 kg and after 5 kg. So like this way we have to carry, according to our specification, the size of the aggregate, we have to carry the sample. Okay. So based on the sample that we have chosen, it will fall under your category B. Okay, grade B will fall. So as per grade B, we have to carry the sieve for 20 mm, passing 20 mm, retaining 2.5, passing 2.5, retaining 10. And we have to carry the sample 2.5 kg at 2.5 kg, and it will fall under the grade B. Okay, and as per this, we have to, there are different specifications for different grades of the grading of the aggregate. Based on this, we have to choose the number of abrasive charges. So for grade B, the number of abrasive charges are 11. For different grades, they are different. It ranges from 6 to 12. Okay, for grade A it is 12, for grade B it is 11. Similarly, for grade C it is 8. For grade D it is 6. So number of abrasive charges that are used varies according to the grade of the aggregate that we are going to take. Okay. So once we take this sample for our grade B, we have to take 2.5 and 2.5 kg of weight of the aggregate, okay, from the chart, and we will choose the ball, abrasive ball. Okay, number of balls as I told you 11. So 11 number of balls we will take, and we have to first take the one dry sample. Okay, for 24 hours we have to heat the aggregate for around 130 degrees Celsius. Once we are getting rid of the water, we can use the sample. We put the sample into the machine with the 11 number of balls and abrasive charges. Then we will start our motor, which will rotate the drum at a speed of 30 to 33 rpm. Okay, rotations per minute. The rotation should be uniform. Okay, there should not be jerking in a single direction. So once the rotation is complete, okay, and the number of rotations also depends on the grade we are using. Okay, for ABCD, the number of rotation is 500, and when it is more than this, it is 1000. Okay, so for 5, so we will rotate, we will count the number of rotations. The when it reaches 500, when the rotation is complete for 500, then we will stop. After 500 rotations, we will stop, and we will take out the sample. Okay, we will take out the sample along with the abrasive charges. We will sieve it under 1.7 mm ISC. 1.7 mm ISC. 1.7 mm ISC we will sieve. After sieving, we will check initial, suppose it is W1, initial weight is W1. This weight after retaining is W2. So W1 minus W2 is the passing weight. Okay, initial weight minus the retaining weight is your passing weight, divided by the initial weight into 100 will give you the abrasive value. Okay, the percentage of the passing through 1.7 mm. Till now we have been using 2.367 ISC. For this sample, for this experiment, we have to take 1.7 mm ISC, not 2.36. Remember this, 1.7 mm ISC we have to use. Once you have to check the retaining. Okay, initial minus retaining, that is passing by initial weight into 100 will give you the abrasive value. And based on the percentage of the abrasive value, we will determine whether it is useful for the pavement construction or not. Okay, if it is within your range of 45%, it can be used for your base course. If it is within 30%, it is used for surface course. And if it is more than that, it is not at all used. Okay, that needs to be discarded. Okay, so any question regarding this? Do you have any question regarding this? Any? Okay? Yes.
Sir, in case of sieving, while sieving means all the aggregate will be taken out from the this machine,
After sieving?
No, after the completion of the rotation.
After the completion of rotations, right?
Then you will put all the samples in 80 mm sieve.
No. First, you will take the sample. You will first check from the stack of the aggregate. We will take out the aggregate. We will sieve it. Next, we will check in which range it is falling. Okay, if the range is falling, suppose 20 mm to 12.5, 12.5 to 10 mm, this range is falling. Then according to the range, we will choose the grade. Suppose my grade has come as B. Okay, for different sizes of aggregate, we have different notifications for your range for your grade. gradation. So this grade falls under for this range of aggregate, the grade is B. So for this, we have to choose 2.5 kg of this sample and 2.5 kg of this range of sample. Then 5 kg of sample we will put together into the machine along with the 11 number of abrasive charges. The weight of the abrasive charges is 395 to 448 grams each abrasive charge. Okay. Once it is put, then and the die is 48 mm. Okay. So once it is put, then it will do the rotations. Okay. So once it reaches 500 rotations, when it is completed, then we will remove it. After removing, what will happen? The samples will not be as same as it was previous. After rotation, this size won't be there. Due to when it will rotate, the balls are there, number of steel balls are there. It will fall freely over the aggregate. Okay, while rotation, this steel ball will actually act as the abrasive reaction. Okay, so they will fall on it will give impact. Okay, actually impact and abrasion both are taking place due to the presence of steel ball. Okay, so when they will mix together, so they will actually give impact and abrasion and they will disintegrate the aggregate. They will break the aggregate. It won't remain in the same, this size won't be there. Okay, most of them will break into small pieces. And we will take the 1.7 mm size steel. 1.7 mm size we will take, and that then we have to see it. And how much it is passing, that we have to check. Passing by initial into 100 is your average percentage of abrasion. Understood? Shubhnil? Ankit? Whatever is what man. Next we will when we will perform the test, then you will understand. Okay, it is very noisy test. You may not stay here for long because lots of sound is produced. Okay, so once it starts, you may